Hi guys, welcome for yet another session at IIDA Summit initiative by the Architects Diary, sponsored Blendin, our global design news app. Our next speaker is Mr. Sushant Verma from RatLab Studio. Sushant Jai-Amita Verma is an international award-winning architect, design technologist, and an educator currently leading RatLab Studio research in architecture and technology that investigates intersection of designs, art, technology through architecture, interior design, and art installations. He holds a master's degree in Emergent Technologies and Design from Architectural Association London and is a former architect at Zaha Hadid Architects London. Being actively invested into academic innovations, he is the leading founder of RatLab Education, Smart Labs, and EduLab India. He is going to talk about smart technologies and smart education, catalyst for innovation in architecture. Giving the floor to Mr. Verma.
Thank you so much, Riddhi, for the introduction. Warm welcome. It's a pleasure to be at IIDA Virtual Summit, and it's a wonderful platform to be on. And I'm really fascinated with the kind of tech that you have used to get everyone together. So I'm really I'm honored to be here. And so yeah, we'll get started with our presentation as well, which is on smart technologies and smart education, a catalyst for innovation in architecture. So, I want to talk about two aspects of. I hope my screen is visible and that's kind of live. So we're going to be talking about two aspects of the profession which I am deeply involved with. One is the professional side of it, and second is the academic side of it, which somehow kind of both intersect in their own ways to create innovation in the industry. And I'm Riddhi had mentioned, like I'm the co-founder of RatLab Studio, which has been in practice since 2012 as an independent small group. At that time, 2015 we started the office in Delhi. Now we have 6 studios. We recently started in Mumbai, in Bangalore, and in London as well, and pretty much in the NCR as well, with the number of studios. So, and I'm also involved with Smart Labs, which is a program which we initiated in 2017 as a hybrid program where we kind of blended online and virtual education together into a single platform. So that's something I'm going to be talking about towards the end of my talk. So talking about the professional side of things, talking about RatLab Studio, how we have emerged into, from a small group and a team of 2 people, which was myself and Pradeep. We started the studio in London back in 2012, where our ideology was to bring in research and technology into architecture, and which we thought could lead to innovation. And at that time, we were obviously exploring technologies such as parametric design, computational design, which we continue to explore, but in different ways and forms. So, as a studio, we've been involved with multiple projects of different scales. We've done like something as small as an art installation or a furniture, to a lighting, to something as complex as an urban plaza, or a mixed use development of 10 lakh square feet, and then pretty much various kind of large institutional projects such as temple complexes, sports arenas, large scale building facades, hospitality spaces, and pretty much different kinds and realms of projects, where the common link between all is technology, which is what I want to focus on today. So talking of the smart technologies, I would let's call them smart right now, because I really feel that they can do much more than what generic technologies which are embedded into the environment in our ecosystem. These do a little more than that, I would say, in terms of efficiency, project workflows, etc. So, giving you an overview of different scales of projects which have been completed, ongoing, work in progress, just to give you an idea of the kind of scalability aspects of these tech. Something as simple as this, which is a set of installations and furniture that we did like back in 6 years back, where when parametric design and sectioning was a very fairly new thing which people are doing now. It's obviously obsolete now, and we kind of do much more than just the sectioning, but this kind of formed the basis of what we can do, what we can create, and understand technologies, how technologies could help us. So through various installations, this was an experience center, a perfumery for Shivas, which we did in Delhi and Mumbai, which was a standalone installation, which was also based on sectioning. Uh, and of course, we did a lot of prototypes, build large scale installations. Then installations like these, which was a part of a facade project we were working on. This is a cellular morphology facade, pretty well covered and featured project at that time. This was in 2015 when we had just started the Delhi office uh, to explore parametric and computational design as new technologies which we can kind of bring into India, because we had just after almost 4.5 years spending in UK and US, I realized that there was a need to bring in these technologies and expose people with these technologies, in a professional realm, education as well. But that's something that I'm going to talk about later. Uh, but how we use computational design over here was beyond what we typically know parametric and computational design is for. Usually we kind of associate it with form finding, creating different kind of forms. But I think how we always saw these technologies was how we can research more into these tech and kind of use them and utilize them and leverage them to create something much more. In this particular case, you see some environmental studies done on a building skin facade, which all of these faces, about 5,000 plus faces, having different values, and we could optimize the workflow to create a design which is also structurally stable. So this was more like an interlinking of multiple tools and workflows, where we could design something, understand the workflow, understand the environmental impact, understand the structural behavior, and kind of combine it all together into design to fabricate something like this. This obviously was a slightly smaller scale project, but it was I kind of the entry level project for us as a studio to demonstrate the potentials of computational design. uh, so of course there were challenges of fabrication, challenges of transportation on the site, and all sorts of other things that we ended up doing. Again, I won't go into depth of each project because I want to keep an overview of different kinds and scales of projects, wherein smart technologies have a major role to play. There were other installations as well, such as the center one that you see is something we did in Los Angeles. The right hand one you see on the screen is also something we did in Los Angeles. This was called Adaptive Skins, where we created a moving building facade system which could move without using any electricity and regulate the internal environments of a building. Talking again of smaller scale installations and interventions, this was another spatial project we did in a residence in New Delhi, where we did this artistic gesture of, kind of a canvas, which is where you see more of a, fluidic language and see these curves kind of blending in. But all of this was basically, you know typical cross sections like this, which is kind of put together and which create this overall morphology. So of course, this is something I believe everyone understands now, how sectioning kind of works, and we can create spatial fluidic volumetric forms using sectioning. This obviously has a limitation of scale, and at which and materiality as well. So when we do this at a different scale, the challenges are slightly different. I'll come to that in a couple of minutes. This was an lighting installation. We've also been developing different products and doing a lot of collaborations with various stakeholders in the industry. So this was uh, one with a lighting consultant which we were working on, and it was a project we did in Saudi Arabia, for which we designed this lighting system where we had these triangular systems which could rotate by about 5.5 degree angle, you know, every different segment, and as it progresses, it kind of rotates into a 360-degree turn. The complexity of that came into the realization of and the engineering of it, basically to understand the detailing, understand the lights, understand the wiring system, and all sorts of other things as well. This was an interior project we did again 5-6 years back, a medium scale uh, experience center for a stone factory, which where we wanted to demonstrate the potentials of how CNC milling and stone can kind of merge. And if you notice, you know this particular triangle or this particular triangle, It's based on a very simple mathematical system. You have a center point of a triangle which is dividing it into three triangles. So we have one triangle becoming three triangles. Then you have the center point of this making nine triangles. Then center point of each of them making 81 triangles. So this is called recursive subdivision. So we basically use recursive subdivision to actually create an algorithm which could be put onto any sort of triangle, with a limitation that it should not go the next step beyond the size of the CNC milling tool which we're going to be using. So we kind of used a machine, a hardware, specification, and put that into the algorithm which we were building digitally to create this kind of a system. Eventually, we had this whole gesture of triangulated, faceted kind of a skin for the interior space, which was all coming in together like this. But the fabrication system of this was actually pretty much done in a click of a few buttons after we had done the algorithm, which could be replicated onto any kind of triangles onto the side. So this kind of became like a tool for us, which you could apply onto any kind of system. And the whole idea was to understand the size of the CNC milling bit and make sure that no ridge is more than the tolerance of this particular size. So it's kind of, intermixing of a machine that you have available or a tool that you have available and putting that into an algorithm. We use a very similar system of triangulation on a facade, which is for a small hospitality project, which was this one. We also collaborated with a fashion designer to kind of create sort of a 3D printed, fabricated dress system, which we could build into a wardrobe, which would control the transparency of a dress using different systems. This is a roof structure project at Delhi Technological University. It's an ongoing intervention right now, which we are working on and detailing out, which has this multi-layered skin system where you have this kind of a triple layered skin system, which kind of controls the microenvironment inside the campus by cutting off direct light and converting that into diffuse light. And the system of that is kind of very interestingly developed as well, which is kind of intertwining of the red and the greens that you see over here in this diagram. Intertwining of these two elements, which is a single curved sheet metal, which was put on a truss system over which you have a covering of PVC sheet. Uh, into parts basically, and the whole thing is obviously responding to the environmental impact that the entire system is able to create a micro environment which is more conducive for more interactions, and activities happening at the campus. uh, a few more projects. This was in Hyderabad, which we're doing a roof structure for a kind of a clubhouse on the top of a housing complex. So, I mean, this shows the kind of prototyping that we did at a smaller scale to understand the system, which could later be taken off into the project. We usually are not able to show a lot of detailing of the project because of the NDAs that we have with a lot of architects who we work with typically. So I'm kind of showing you the glimpse of a lot of projects without much of detailing, of course. uh, then we also end up developing our tools and techniques. So there are tools where we work on a lot of facade projects. So these are a few tools that we developed where, for the facade, for a double skin facade, where we triangulated the entire skin into a system which could be the fabrication data for which could be sent to a machine, and it could be fabricated and then it goes to the site and being put with all the numbering system and everything organized. So you have a facade which is, in the factory being made like this, and every single element has a numbering system, as you can see, with which also shows this R is the running length of the tool. So if you know the running length of the CNC machine, how much of CNC is required, how much of time is required, we can actually estimate the costs of the facade while we are designing it, basically without going into the typical process of getting the quantities, BOQs, and getting onto the costing of the overall structure. This allows us to obviously, innovate much more better. Just running through this video, which kind of shows the whole process of how from the design to fabrication process of this particular facade system. where we are able to automate the entire fabrication data through multiple iterations. We are able to calculate the running length, we are able to calculate the time, the machining time. And all of this is done through tools like Grasshopper and various kind of plugins that we create within Grasshopper, which uh, I would call somewhat advanced coding for design. And yeah, we can then work with a tool, create different iterations, create different ideations, and use that to understand which particular one is more rational, which is more cost effective, and again take a call accordingly. Here we are also understanding the visual analysis of the interior space with respect to the facade using a genetic algorithm. Other sort of projects. This is again a project in Hyderabad we've been working on for a developer, which kind of wanted us to develop some kind of fluidic gesture, where we kind of simplify the system and rationalize the geometry in a manner where we could 3D print it for the facade engineering team to understand, uh, link that information with the environmental strategies. So within the parametric model, we can rationalize, and you can see this color coding on the right hand side, which shows different types of members that are available. So we can really reduce the number of types rather than having every element differentiated, which a typical parametric system might produce. We are able to create something which is much more modularized to as much extent to control the cost and the feasibility of the project. I spoke about sectioning at a smaller scale when we were doing furniture and different other kind of art installations. On a larger scale, when we go on a larger scale, the complexity and the detailing of that completely changes drastically. Although the gesture is something that we can really use and utilize to create sort of a different iteration. This was again from a few other projects. This is another facade project where we had different modules which are kind of protruding out from a particular uh, flat surface. And but if you look in deeply, I mean, there are four kinds of panels which we are playing around with and configuring in different manners. And just by configuration of these elements, we are able to create different modules, which all of them have an impact of different opening sizes and percentage. And if we have different opening sizes, we can really play around with that to control the kind of light and the behavior of the building skin inside the building as well. All of that is rationally always. I mean, we don't usually typically only work on a geometry or a form. That usually goes forward when we are creating the value engineering for that particular form as well. So here you see a lot of radiation studies and the daylight studies on the floor plates, and understanding how the behavior of this particular skin is going to be. So these kind of analysis help us understand that, okay, whether this particular facade system is going to be more workable for, let's say, south direction, east side, north facing, west facing, and accordingly we can take an understanding of how it behaves basically. So we're not only looking at a particular form in terms of its aesthetics, but we're also looking at its behavior and its impact on the particular building and the environment as well. So you see these various kind of technical analysis. This is what we call the value engineering for the facades, where we're looking into the environmental aspects, and then we also start to look into the structural aspects and other differentiated aspects of the facade. Here we are able to use this as a second skin to understand how we are able to reduce the kind of heat loads onto the building if we use it in different directions. This is a cricket stadium project we worked on. We were developing a little tool for developing more of a toolkit, which we thought we'll probably release as a as a grasshopper tool at one point. Uh, but what we were looking into was mostly how we can kind of automate the design of a stadium. In this particular case, we ended up designing the stadium for this particular project in Queensland in Australia as well, which was a collaboration with the local architects over there, where we evolved the entire design into a fluidic roof system, which has a gentle lift on one particular side. And then of course there are panels which are changing, and kind of variable which form the roof structure, which we're still working on at the moment. This is another project which is a religious project, institutional project. It's a Sai Baba temple in India. It's in South India, uh, which is again ongoing right now. Here the design brief really allowed asked us to kind of work on something which kind of correlates with Vastu. So we had this whole correlation in Vastu of and a numerology of the number 11. So we were asked that number 11 is absolutely important for this particular project, and we wanted to conceptualize everything around that. So what we did was we developed a hendecagon. Hendecagon is an 11-sided polygon. Uh, and we created different articulations of a hendecagon, and how we can use different geometries to create different formations, and then develop that into different kind of forms. So that allowed us to create various kind of algorithms which could allow us to create forms which look into structural aspects as well, and the spatial aspects of the project. So within the multiple options and iterations that we ended up creating, and again, this creation is not something that happens on a click of a button. It requires a lot of rigor to create a system, to create an algorithm, uh, and then it leads to something. It's not like the computer would design for you. You have to feed in every single aspect into the computer and make it design. It's pretty much like how you have a digital pencil, and how you use it is the kind of output it's going to give you basically. But it allowed us to explore a form which was spatially very interesting, which where we can really play around with a lot with light and shade, and how the light is going to come from the oculus on top of the temple, and ended up creating something of this sorts. Again, there are different elements like facade, structure, modularity, the inner columns, the various elements, flooring patterns, which obviously we had to look into deeply. uh, Now, this is an ongoing project, one of the very interesting ones which we've been working on. This is on the site, pretty much uh, 50% construction already done. This is in Dwarka in New Delhi. It's going to be the largest theme park in India, which is actually spread across 220 acres of site. And we were brought on board on this project to make a parametric modeling of the existing design ideation that the team had. And there are various consultants on board, some from London, some from Delhi, and all of us collaborated on this to work together to create this complex structure. It has this you know various kind of sky bridges. I mean, there's one sky bridge basically on different pylons, and we had to do the parametric modeling of that, which I would say is a combination of BIM and parametric modeling, where every single element which is going to be constructed was parametrically modeled, numbered, sequenced, and sent for fabrication. So what you see over here on the right hand side, you see the posters of the project, which is from the site. On the left hand side, you see a parametric model that we've created, where you can kind of see all sorts of details of the element. So it's not just a form basically, it's actually a highly detailed parametric model with the structural elements in place. And this is there are three kind of pylons in this which kind of hold the sky bridge. And it's a 45-meter tall structure, which uh, which has a central core, and you have a digrid which you see over here. Now the digrid is actually holding is basically holding the staircase, which is cantilevered on the inside, and the core is independent of the staircase, and the core is holding these cables, which is holding a sky bridge which is going along the entire park. So obviously it was a very very challenging project in terms of how we would model every single element, because you're dealing with millions of elements actually. So we had to really uplift the kind of computing that we had to do, and we had to create a lot of custom tools to be able to create this system, which also factors into clash detection, structural aspects, and all sorts of other things. So here you see all the pylons over here and the sky bridge, and these are the master models from Rhinos snippets, whatever we can share. Of course, a lot of it is it's a government project. A lot of it is not something which can be shared. But then what you see over here is a parametric model at a particular stage where you see a triple skin digrid, and every single element is welded to each other through a single node. Now that node as well had to be designed, detailed out parametrically, and every single node's dimensions and articulations are different, and that had to be numbered and sequenced and used for the fabricator for construction. So this is what you have, and this is the snippets of the working of the parametric model, where all the clash detection studies were done, all the scripts were built, all the algorithms were built to model the entire thing, which ended up into these different digrids. This is where the sky bridge comes basically at this level, which is 30 meters, as you see. So this sky bridge has cables going in, and no cable was allowed to clash with the digrid system. Now this was a very challenging system, and we also had to resolve the inner skin and the cladding system of it, which is still in progress, and we had to make a parametric system which was modularized, and each cable was then numbered. All of this data was put into automated to put into an Excel sheet, not automatically, I would say. Automation is the right word, I would say. And we had to look into clashes, that where would this particular cable clash. For example, the clashes are marked here on the screen over here. Now that is something we had to avoid. So we had to really work around iterations of this complex structure to make sure that what if we move it with 3-degree angle, what if we move it with a 0.68-degree angle to make sure that there are no clashes. So we had to go from all the reds to all the greens. So the optimization of all the elements had to take place with respect to the tender drawing, and how it could be led to the final project. And these are a few more snippets. Again, you would see a highly detailed uh, parametric model. Every single node is numbered, the angles, what how you could assist the facade consultant further, and the structural team to give in the data wherever required, and also extract all sorts of drawings from the 3D model that we had created out of this. So for example, we were also looking at deviations. For example, if we convert all the double curved surfaces into flat surfaces, how much of deviation are we looking into? So we had created these like simple systems or tools to calculate all of these aspects as well. So we're not always analyzing only the form, we're also analyzing variety of aspects from the form as well, which we were looking into. uh, how we've been working for the past many years is, we have been doing a lot of independent projects, but at the same time we've also been working with a lot of architects and designers, not just in India but outside of India as well, wherein we have been collaborating with them to create uh, sort of a collaborative model where we can help them with the kind of tools that we've been developing over the period of time. A lot of tools are not like out there, in terms of those are internal in-house tools that we keep on creating. So what we recently launched is we kind of converted this entire model into a subscription service for different architects. So which is called Ratla Paratech. It can be found on our website as well. So any architects or designers who kind of wish to collaborate with us now have found a very simple way that we have this SaaS system where it's a subscription model basically, uh, where they can subscribe to the parametric and computational design services without actually having to build their their entire research lab basically, to do the tasks. So this way we are able to cater to much more number of professionals out there, and who are able to take our services and subscribe to our different models. So this is called Paratech. This is something which we recently launched. uh, Now, this was one part of it, which is the professional side of it. Now, let me talk about the academic side of it. So, you know, when I was, of course, exposed to different kind of an environment in other countries while I was working there. Uh, I was working with a robotics company, RoboFold in London. I was working with Zaha Hadid Architects in London. Then I moved to Los Angeles. We were doing independently working over there at the Mac Center and museum. Uh, so overall, what we experienced was that the education system in India has not been at par to expose us to the right kind of tools and technologies. So we always had this mission of creating an academic vertical. So when 2015 we started the studio. Pretty much around the same time we started RATLab Education as well. RATLab Education is another vertical that we've expanded into in multiple arenas now. When we were challenging that how smart is our education, that's something that we always have this question, that how do we make our education system smart and much more comprehensive to adapt to the new technologies that are available to us right now. uh, at that time, when I'm talking about that time, I mean, I was really questioning about what the kind of education system that we had. So of course we saw that, okay, 150 200 years back, this is the kind of classrooms that we had at that time. And now the classrooms have changed to this, so nothing much has changed in terms of technology's integration into it. So we always thought, okay, the effect of technology on modern education has been slightly different, that we've introduced tech to the students, but again the behavior is very much the same. And this is something that we can also relate to the pandemic and how the shift to the online education system has happened. So uh, but while that was happening, I'll come to this particular part when we address the hybrid nature of this education. But while this was happening, over the next 5 6 7 years, we did about 125 plus workshops catering to about 2000 students and professionals, where we did a lot of summer schools, winter schools programs, different kind of workshops in different cities. uh, and over a period of time, we realized that we had been like doing different workshops, and ended up creating a lot of design modules and workshops ranging from a 2 day studio to a 6 month program. The 6 month program was the most fascinating model that we had at that time. In 2017 we started smart labs, but while we were doing that, we were also doing a lot of workshops in different countries. This is snippets from few workshops we did in Taiwan in 2014. This was a few workshops in New Delhi, where we were, creating something, teaching different tools to different architects, different students, building installations, and trying to create a physical sort of an output so that students can get a hands-on experience with the digital fabrication tools as well. But before we get onto that part, I think students must master the software before they master the hardware as well. So that is something very important, and it takes a bit of time. So for that, we usually keep on creating different kind of workshops and programs, and which one can be a part of. So I'm just gonna brush through different workshops and interactions that we've had over the period of time at different institutions, different programs. This is, I think, one at Taiwan. This one is a right one is at CEPT. These were a few workshops in Bangalore, Chennai, Chandigarh, Pune, plenty of other cities that we've done different workshops at. Mumbai, and what happened in 2020 when the pandemic came is we shifted the entire model into a global visiting school, which was more of online, because the pandemic has stuck, and we realized, okay, that we need to move into a different mode of education. So this is where we started to introduce technology in different ways, where we could get a lot of tutors onboarded with us from different parts of the world and create sort of an education system. Over a period of time, over the last 3 years, we've been expanding GVS into a platform where people can either be a part of the live workshops, or even get access the recordings and the example files from different workshops of different kinds. So over here, what you'll see is a glimpse of GVS 2020, where we had different kind of workshops on fluid modeling in Maya, processing, creative coding, augmented reality, and all of that kind of became a very interesting program. We had about, I think, 250 plus students participating in this entire program across different clusters, and we could really engage and teach the students about technologies. How do we augment reality? Using processing, creative coding, and various other kind of technologies that we integrated into the program beyond just the grasshopper, which we were already doing in practice as well. So this kind of became a very interesting model for us, which kind of uh, there was robotic fabrication, generative art, and all sorts of things. And next year we had another set of workshops which was dealing with tools like ZBrush and Grasshopper, Cinema 4D, Python, Maya, Blender, and this year 2021, 2022, GVS is already going on right now. We've had about 3 clusters already. There are two more online clusters are left, and there is a workshop happening in London in September, which is on I think 23rd to 25th of September. It's a 3-day workshop happening in central London, which I am leading alongside other tutors from London. And that's a physical in studio workshop, which kind of combines with the other online workshops of GVS. So we're having workshops on Touch Designer, Maya, Blender, uh, machine learning using Python, and of course Grasshopper and Rhino, which is happening towards the end of the program. So all of this kind of has been providing as a good tool set for a lot of students to kind of learn and enroll for. And across these 3 years, we've had about like about 20 odd workshops and programs, and all of this is available now for anyone to go back to access, get the example files from the tutors, and self-educate. This is what our aim was. How do students self-educate? Because if the system is slow to change, you don't have the kind of exposure. uh, might as well use the online technologies to kind of uh, self-train yourself, basically, I would say. But during all this time, we were again asking the same question, that how smart is our education? Like, how do we combine all of this into a hybrid situation? So this is where we launched Smart Labs program in 2017, which was Smart Labs 1.0, which was a pilot project for us, which was a collaboration with a Chennai-based university. We collaborated with the RVA School of Architecture in Chennai, which supported the program to create it into a hybrid system. Now, 2016, I'm talking about pre-pandemic times where nobody had understood how the online education would work. I don't think we had Zoom or these kind of platforms at that time. We started with Skype, Go Meeting, and all of these kind of platforms, and later moved on to Zoom, uh, wherein we could create a system where we had studios happening, all the tutorials, and then which was facilitated by online sessions across the 6-month program. So it's a 6-month program which anybody can enroll. Initially, we opened it only for Indian students, and it was meant only for the Indian universities. Second, where we could, train them, make them go through a process of fabrication, where they build stuff, use the techniques and technologies to kind of create something. We had students which were like second year architecture students to graduates, which had graduated like 5 years back as well, and all of them coming together to create systems, learn technologies, learn these kind of tools. So now, 6 years down the line, we are at SmartLab 7.0 right now. SmartLab 6.0 is about to culminate soon. SmartLab 7.0, we are screening up admissions for that. We are already onboarding students for that from different parts of the world. Now it's a global hybrid program, which is a major chunk of it happens online, and it's facilitated by studios that are happening in New Delhi, where we run our studios, where students can travel, be a part of the studio, get in touch with the fabrication tools that we are using, understand digital fabrication, and explore different kind of tools across a 6-month program. So this way, it's a very flexible program where students can actually uh, uh, enroll from any part of the world, and the studios are optional. The online sessions are something which are the center focus of it now. And students collaborate with each other. They work on different projects, and at the end of 6 months, they usually have a very good base to go on to any masters, and they kind of train to kind of make the best out of whatever program they're in. We of course had very interesting associations across different batches of Smart Labs with different tutors from different parts of the world. The agendas are focused on digital fabrication, interactive design, performative design, and where students learn different kind of tools. For example, this was the interactive design module where uh, student is able to create this interactive skin system where you're using the motion of the hand, using a leap motion device, and integrate that into Grasshopper and Rhino to create a sort of a surface. So these were like one of the many explorations that the interactive design session had. This was again when the studio sessions were more relevant in Smart Labs, and the online sessions were the facilitating ones. Now it's kind of flipped where the online sessions are more important because we have a huge bunch of students from the other parts of the world as well, who who would possibly have a travel constraint, of course. So we let them work from their own cities and create different kind of systems. And at the end of the program, we have an exhibition, we have a conference happening, uh, and which is where all the works of the students is well documented and put together into different systems. When we have the studios, we look into 3D printing, we look into different tools, we introduce them with industry tools, CNC machines, laser cutting, and all sorts of other things, and make them use it in the right way. I would say the application of the tools is really important, which is what we try to focus on. And these are again few snippets of the student work that they've developed over different batches, where they explore different you know spatial formations and articulations of these technologies, and start to use these kind of tools to create things. So again, right from installation to furniture to architecture to 3D printing stuff, all sorts of things are continuing to go on. So overall, I would say, this is like a catalyst. I would say, for the innovation that is happening in the industry, because across, I think in the last, 6 batches of smart labs, about 200 people graduating out of it. These students are either right now working at senior positions as computational designers into known practices across India and other parts of the world, or are pursuing their masters and flourishing because they had a good platform and a base made during this kind of hybrid program, uh, or kind of taking up teaching positions and even interacting with us as tutors at Smart Labs as well. Many of the times, people at Smart Labs become a part of the Rat Lab studio as a team member later on, because they are well trained to kind of use these tools and apply them into the professional stuff as well. Overall, when I talk of innovation in the industry, I think innovation in architecture is still at the early stage. Not even the early stage, I would say. I think the only this is a diffusion curve, which is a typical talks about how diffusion happens across 2.5% of population of innovators, early adopters, early majority, late majority, and 16% laggards. Innovation in architecture is still stuck to the 2.5% of population. So not many people are still adopting to it. Although I would say in the last couple of years, things have started to change, and we are also slowly moving towards early adopters. So I would say whoever is able to experience these kind of technologies and innovation, if you really want to make an impact, I would say jump onto it and start to learn and build up your skill set. And the quicker you I would say learn these skill sets, you would be able to use them in practice and academia both as well. So yeah, I think at the end, I would say how this is how, for me, innovation and technologies combine in profession and academia. And if you want to get to know more of us, you can check out our website or shoot us an email, or follow us on different platforms on Instagram as well. RatLab Arch is the architectural studio. RatLab EDU is where you'll see information of all different workshops that we've been doing and taking up. And then you have the smartlabs.ratlab link, where you get all the information of the Smart Labs program. So within these three interesting verticals, we are able to uh, we are trying to innovate in our own ways, and it's been an overwhelming journey so far. And yeah, I wish to have interactions with the people who are able to be a part of this forum. And if you guys have any kind of questions, feel free to shoot up.
Then we can start our session. While we have any other questions, I have a few questions if you don't mind me asking.
Sure. So
Yeah.
that has also
So,
put up a question as well. Yeah, but yeah, I'll take that up.
uh, so you were talking about material limitations while during parametric design and the scale. So, especially the 3D printing. So, what kind of materials do you usually prefer or use in your projects, or have you used in your
Right.
projects?
So whenever we're designing something, we have to understand. I would say it's not like, I know there's a lot of misconceptions that these materials are not suitable for parametric designs because the kind of geometries are complex. Now there are so many materials out there which are already have a different play of geometries, which one can kind of utilize in different kind of spaces, which they call as parametric products and acoustic ceilings and all sorts of other things as well. So I would say uh, there are no limitations as such because we can use any sort of materials. To be honest, there are limitations in terms of when we play around with geometries, we have to understand the scale at which we are working at. For example, if we're working on the sectioning process that I showed initially, it was at a smaller scale, of course. At a larger scale, when we go to the facade, the entire system has to be made with an MS structure, with an aluminium cladding sheet, and the detailing of that is completely different. You have to look into the node details, you have to look into the intersection detail, the interface detail, all sorts of other things as well. So I think the focus kind of shifts towards uh, uh, different kind of aspects of the design and then construction. It's not, because when you're creating something more complex which is not very conventional, you have to go a step forward to I would say to justify it sometimes, or to make sure that it happens and it's built at the right kind of cost as well. Usually there is again misconceptions that parametric geometries and designs are more expensive than conventional ones. That is not true actually. In fact, we have really means to rationalize and optimize things to a much more doable extent. Of course, if one does compare that with a simple brick wall, obviously there's no it's a no brainer. Of course, a brick wall is going to be much more cheaper than any design that you're going to be doing. So, but yeah, if you compare, even we do facades, for example, a typical facade, if it costs 600 rupees a square feet, we have worked on parametrically designed facades which are costing 400 rupees a square feet, and it makes a huge impact on the overall project as well. So it's not always that it's limitations are there. But in terms of materials, in facades we work on typical aluminium, zinc sheets, MS structures. uh, so all sorts of things are there. We work on composite panels. uh, Everything right now in the industry can be CNC milled or water jet cut. Even steel can be water jet cut, basically. So there's no limitation as such. There are technology, there are hardwares available for all of this. There are machines available. So it's just about finding the right way, I would say. Yeah.
So, you would say it's just the scale and the kind of project which decides the material. Uh,
Yeah, absolutely, absolutely. For example, the temple project, it's a large scale project. We're dealing with a huge uh, angled structural system which kind of combines together to. So we're looking into simple concrete construction, which can be not going beyond a steeper angle and stuff like that. So all of that is possible, and then we can look into ferrocement and various other kind of materials that one can use to create jalis. We can use GFRC. GFRC is a very common material now, which you use for like typical jalis across various kind of projects, and it's not very expensive as well. So there are ways to bring in innovation in different ways. Materials is not a problem, and 3D printing also, like you mentioned. 3D printing is a prototyping technique which can allow us to understand something. A lot of people don't really get the whole idea of 3D printing because people still think 3D printing is a new technology. 3D printing was patented in 1986, so it's actually uh, a 30-year-old technology, I would say. So there's no it's just that now you started to adopt to it, and now you started to think that, okay, 3D printing is cool, let's 3D print something. But the thing is, what does 3D printing give you? Is it giving you uh, is it giving you a small scale version of the design? If it's just doing that, then it's the same as a 3D model. It just, you have to have it physically in you, but it won't have the detailing. So 3D printing is I particularly find 3D printing as a very underutilized technology, because people are not using it for prototyping or as a part of the project. And of course, you can't 3D print a large scale building right now. A lot of research has been happening. There are there's a lot in the news that okay, we are able to 3D print a room, a school, and all sorts of things. All of that is there, but there's a long way to go in terms of and when it can actually build uh, materials or large scale buildings as such.
Thank you so much. We'll go on to our next question. Does this technology has real life adaptation?
Yeah, I mean, we're still surviving as a studio, so we're doing all sorts of projects, and yeah, we're building, we're doing things, and although architecture is a slow process, so as I mentioned, like a lot of things is something that we is under confidentiality norms, and we can share a lot of things. And to be honest, I don't think we've updated our website as well in a long time. We've pretty much put everything on Instagram and stuff, glimpses of things that you're working on, because a lot of times it's a very long shot in terms of architecture takes time. It takes like 4 5 years for a large scale project to get to see the light of the day, and there's a lot of R&D that goes behind the scenes as well. So but I can tell you that we're working on a lot of things which are getting built. It has all of this has a real life adaptation for sure, and utilization. So um, and I would say every architect, every designer right now is looking for these kind of tools to adapt into their practice to bring about a change. So that is definitely happening right now, and it's no more a talk of the future, it's a talk of the present right now, to be honest.
So, there's the next one is what do you suggest as future opportunity for a student?
So I think students really need to, take this opportunity right now. There are so many technologies and there's so many open source learning platforms available. There are so many free platforms available, like which can give you the sort of, I would say, the learning that you would not get otherwise. Because you know it will take time for the institutions to adapt to all of these technologies and tools, and get the right resources to be taught as a part of the curriculum. Till that happens, while that happens, like there are new technologies out there always. So it's better for students. I would encourage all the students to learn as many new technologies that you can, rather than just seeing it from a distance. And it should not be just seen on Instagram and Pinterest. Like one needs to learn these things, and it takes a lot of these tools have a very uh, different learning curve, I would say. Some are quicker to learn, some take time. And that's pretty much why we also started Smart Labs as a 6 month program, because we realized that students learning through a 2 day program or a 3 day program are not really making the best benefit out of it, to be honest. And you need a consistent uh, interaction with the tools to be able to make the best out of it. It's not something that's you can. There are no shortcuts, I would say. There are no shortcuts available, and people can do some quick things with basic tools, but then to get deeper into it, to actually use it in the profession, you need to have a strong expertise, and that requires time. So the students need to start learning these tools, whatever tools are available, whatever new technologies are there. I think it's the opportunities are a huge. Everyone right now is looking for people. There are job opportunities as well. There are teaching opportunities. If you really want to make an impact into the future of the profession, you need to know these tools. Gone are the days when you can survive with knowing basic 3D modeling and good rendering skills and stuff like that. It has to go beyond that as well. So yeah, I'll take up the next question as well. Siddharth's asking, is Smart Life 7.0 will be a course software? Will we get to know the use in a practice like you do in a firm at the end of the course? How will we get into competition? Okay, so this is exactly what the whole crux of Smart Labs is, that the whole idea was to expose students to practical applications as well. So we have theory sessions happening in Smart Labs. We have technical sessions where we teach softwares. We have interactions with tutors happening. We have real life projects happening and bringing it into the studio. So students over the 6 month period are not just learning but are also applying into projects. At one way, it's kind of building a good set a portfolio as well for them to apply for masters or use it in their profiles and stuff like that. they are learning the application. So Smart Labs is all about applying the skills. So we're not just building the software skills. I, I, I mean, at this time, I really feel learning software is very easy. There are so many resources out there. If you are dedicated, you are consistent, you can learn. But the application is something that you need some sort of mentoring. You can't do it unguidedly. You just can't be opening a YouTube tutorial and learn how to build, to be honest. It's the same way you can't you can learn AutoCAD through online, through YouTube or other kind of forums, for example. But you can't learn how to design. And this is the right example that I would give for computational design as well. You can learn how to use Rhino Grasshopper using the Grasshopper primer, or a book, but nobody can teach you how to design using that. So that comes with practice and consistency, which is what we try to inculcate into the smart class program, basically. So at the end of the program, we really nurture experts, I would say. That's what we like to take pride in at this point when it comes to smart labs.
So, speaking of that, someone's asked, do you think the architectural institutes are lacking the progressive thinking? And what are your suggestions for them?
Uh, I think, if you would ask me this question like 2 3 years back, let's say, 2018, 19, I would have said yes, damn yes. I mean, they're lacking in progressive thinking for sure, because it's too slow a change, and that is where all these workshop culture has flourished in the last few years as well. Um, I think when we started the workshops for AtLab Education, it was 2015. Nobody was doing workshops. It was absolutely new. Like we were kind of the front runners for doing grasshopper workshops at that time. And then a lot of time it kind of scaled up in different ways, and we also scaled up in many ways to create these 6 month program and all sorts of things. And then global visiting school happened. uh, but now, if you ask me this question, I think a lot of institutions are wanting to change for sure. Their adoption rate might be slow, but they are definitely wanting to change, and they are uh, trying to adopt to things. The systems are slow. The administrative systems I find really slow, and I won't be diplomatic here. I deal with a lot of institutions, and I openly tell them as well, that if you really want to change, you got to be fast in this, because by the time you adapt to something, there are new things out there, and the students are wanting to learn more. So, but I think things are slowly becoming part of the curriculums. I really believe in open learning culture. I don't think learning should be restricted to a particular institution. If an institution goes forward to create a sort of a program, they should open it to everyone, I would say. And that's pretty much how the innovation will happen in the industry as well.
What are the preferred softwares or tools in the European market?
Uh, so I think everyone right now is definitely looking for Grasshopper experts, I would say. So Grasshopper has become a very, very key tool in the profession. Almost all the projects that are getting built, designed and built, they are using Grasshopper in some way or the other. It can be rationalizing of the geometry, it could be sorting of your data, it can be facade design, it could be landscape, lots of other things basically. So Grasshopper is a much more realistic tool, which is grounded now, which can link to actual information. So Grasshopper is definitely much required tool, and the requirement of that is definitely there in all sorts of job profiles also that you would see. It's a much preferred tool. Revit, of course, has also been there in the industry for a very long time, and the demands for Revit has also been high. But with the kind of complexities and designs that people are trying out, uh, there is a sense of merger required between Revit and Grasshopper as well. So hence there are other tools like Dynamo, and then conveyor belt, and all sorts of other plugins within Grasshopper that are being developed, which can allow you to interlink geometry between Revit and Rhino and Grasshopper as well. So I think, but these tools I would say are much more preferred. And then of course now a lot of people who are getting into fluidic forms and stuff are also delving into Maya and using kind of Maya modeling and creating fluidic forms and stuff. But again, Maya has its own kind of restrictions in terms of it being more intuitive, I would say. But if you ask me, like one software which one must learn at this point, it's the depths of Grasshopper, not just from the face of it. It's the intermediate and advanced levels of Grasshopper. So that means a good amount of time spending with the tool, and that's where you can start to integrate that with other tools and technologies as well. And that is now required in the Indian market as well, by the way. So it's not just the European market. Indian architects, I can name 10 architects, like pinpoint them that the biggest of architects who are working right now, they need Grasshopper skills. So it's a need of the hour.
So grasshopper it is. Everybody needs to learn that. And do you think you we have skipped few trends architecturally in the fast changing world?
Um, I mean, it- very subjective question. So I'll have to give a subjective answer because there's no objectivity of styles and trends, basically. Like, because that's very subjective always. Like, typically when we, you know, come out of a particular style or an era, that's when we realize that okay, what we were doing before, not when we were into it. Because right now everything seems fast changing, but if you go back 50 years and if you ask someone that how do you think things changing, they would say okay, fast changing right now for sure. I mean, right now we see it in a different way because um, so it's always going to be evolving, I would say. So I don't think anything has been skipped or anything. New trends keep coming and going. That's always going to be there. uh, I myself particularly don't believe in architectural styles or a particular set of style that one needs to have. And that's pretty much is reflecting in our works as well. That you would see some sort of complexity involved in different kind of forms, but you would see simple things, elegant things, complex things, ugly things, beautiful things, all sorts of things, basically. So everything is there. Uh, so I would say I don't believe in styles that much, so I don't think we have really skipped styles. But I think we are moving at a good pace in terms of adoption with technology, and there are new tools and techniques coming in. So one must start to leverage them and start to utilize them. But if you see the overall current phase of architectural style, if I may say so, it's very much tech influenced for sure. The tools will always reflect the kind of output that you will have. That has happened when you were drawing with a pencil. That has happened when you were using a parallel bar. The moment there was the set square was invented, you started to see things at angles. The moment French curves came into place, you started to see plans and various kind of forms in curvilinear style. So there is no denying that styles have always influenced design language in some way or the other, and there's nothing wrong in that. Right now we have so many tools available to us, hence we are working on multiple kinds of styles overlapping. So let's see what survives and sticks around till 2050. That will become a style.
Thank you so much. Our questions are ended, and thank you for giving a paradigm to our audience. It was a great time having you at the summit. We are taking a break till 4:30, and there'll be another session right after the break. Do do not forget to tune in. Stay safe and please network. Sorry, I'm sorry. Please network with fellow attendees in the network lounge.
Definitely, it's a pleasure
There
being
is
here.
one
Thank you
more
so much
question,
for making me a part of
Sushant,
this conversation.
Ritik. There is one more question. I think you guys should
I
take.
haven't
There is
received
one more.
it.
I
Okay,
can see it on my screen. Yeah.
there's yeah, it's just popped up. Yes. Hi, Sushant. You're a pioneer in pushing tech in architecture in India. What is your opinion on parametric computation flourishing in India? Is it more as an external consultancy or the architects adapting these tools themselves?
Uh, so, I mean, it's a very good question, actually. Uh, and thank you for the kind words at the beginning. So, I mean, no, I mean, we're really trying hard and we take a lot of pride in trying to push the boundary. And it's not an easy job, I would say, I can tell you for sure. But because we've been trying to bring about a change in many ways, bottom up, top down, professionally and in academia both, it's a hard battle, I would say. But I think we're pretty much happy with how things are changing. And but when you say in terms of how it's flourishing in India, it's definitely flourishing in India at a very high pace right now. And I think the biggest force has started from the student community, from the young people out there who want this change to happen, who want to explore things. They are just confused right now. Many of them are confused right now that how does this get built? How does this get accepted into the profession? But let me tell you, give you a ray of hope over here that every professional out there right now is looking for these technologies, tools, and the kind of people who know these tools, basically. So it is definitely flourishing. It's a merger that is required right now between the young people and the practicing professionals. That how this will be actually adopted in a larger way. And right now, it is really flourished in India. It's very popular. People know about it. It's no more. We don't have to struggle to tell somebody that okay, we're doing something called parametric design, because like again, 5-6 years down, back, people used to ask what is parametric, what is computation, what do you mean by computation, and like so many other things. And now it's become very easy to explain it to a layman as well. Now clients come to us saying I want a parametric facade, and I ask them like, are you a designer? They say no, you know I'm a layman, but I want a parametric design. So it's become that popular now in that sense. So in a way, I think it's really flourished now in India as well. We should not shy away from the fact that it can't be done. It's all happening. Technologies are there. Industry is ready. That I can tell you. uh, and is it more of an external consultancy or the architects adopting these tools themselves? I think it's a mix of both. Architects are adopting these tools themselves. The limit to which that they can do is obviously limited. you know we as a studio have been doing independent projects as well. So the way we adopt to tools is very, very different to how another architect who started adopting to these tools 2 years back is going to be doing, of course. uh, and it's not always that we are always good on they are bad and something like that. It's not a comparison of that kind. It's a kind of intervention that you can to which you can use technologies. uh, but at the same time, because architects can do only to a particular to a limit, I think there are a lot of consultants out there. I mean, likewise, I mean, we are doing external consultancy to a lot of architects and designers, where we're helping them to push the boundary using technologies. And I don't think everybody has to be an expert in this, to be honest. I truly believe that, for example, if somebody has an expertise in designing landscapes, they are landscape experts, they are landscape architects. We usually consult with them as landscape architects. Somebody has an expertise in lighting, we would consult with them for lighting design. It's not like me as an architect would not know how to design a landscape or how to do good lighting. But I think if there's an expert out there who can do much more better and who's much more exposure and experience than I would have, then obviously I would work with that particular person or a firm as a consultant. So it is important to have different kind of consultants. So computational and parametric design consultants has been an emerging thing now. How many people are actually truly sticking by the right use of it is something that's still questionable, I would say, because a lot of people just knowing basic stuff are able to provide services, but then those services are not at par with what's happening internationally and globally. So but it's a flourishing market, I would say. And I think it's all about collaborations between different consultants. There is no single architect or a firm that would do everything by themselves. So everybody has their own role to play.
Thank you so much, Mr. Verma. And I would agree on what you said. Like, I also believe that if a project demands a certain specialty and an architect has a vision, so as many consultants who can actually make that vision possible should collaborate and make it happen.
Yeah. So yeah, looking forward to keep these interactions on. And I know like uh, we've had a few questions answered, but again I can't see the people's name and stuff. You guys want to drop in some questions after this forum, please, you can do that on Instagram as well. So uh, feel free to create some kind of interactions. I mean, we're fairly becoming more active now on social media as well in terms of interacting, and our response times have become better having some dedicated team members to help us out on this. So yeah, looking forward to these kind of interactions, and hopefully students find, students or professionals, whoever was a part of the audience, found this conversation useful. And yeah, looking forward to more such associations in future. And thank you so much again, once again, to the Architects Diary and IIDA for having this summit, and it's been a pleasure being a part of it.
It's been a pleasure having it with you. Um, so now we'll see everyone at 4:30 for the next session. Stay safe and network in the network lounge.